Today, in this video, we are going to have a revision about the graph of motion. There are two types of motion graph, distance time graph and speed time graph. Distance time graph displays the distance from an origin point over a period of time. Speed time graph displays the speed of a particle over a period of time. Here are some key properties about distance time graph. The gradient represents the speed. A steeper line indicates a greater speed. A horizontal line shows that the object is not moving, that is, the speed is zero. Some key properties about speed time graph. The gradient represents the acceleration. If the graph is increasing, the object is accelerating. If the graph is decreasing, the object is decelerating. A horizontal line shows that the object moves in a constant speed. The area under the graph represents the distance traveled. Here is an example of a distance time graph. Diagram below shows the distance time graph of Jay's journey by motorcycle from Bandar Aman to Bandar Celia. A. Jay took 45 minutes for his return journey to Bandar Aman. Complete the graph for the journey. Jay took 45 minutes to get back to Bandar Aman from Bandar Celia. From 90 minutes, added with 45 minutes, Jay reached as 135 minutes. To complete the graph for the journey, a line is drawn from Bandar Celia to Bandar Aman within 45 minutes. B. Based on the diagram, calculate the duration of time in minutes Jay stopped at Bandar Bestari. Now, we are looking at the flat part of the line, where Jay is at rest in this period. 30 minutes till 60 minutes. 60 minus 30 equals 30. Jay stopped for 30 minutes at Bandar Bestari. Next, calculate the speed in km per hour in the first 30 minutes. Looks at the part in the first 30 minutes, Jay has cycled for 20 km. Since the unit of speed is in km per hour, we convert the minute to hour. 30 divided by 60. Find the speed, we divide distance by time. 20 divided by 30 over 60, the calculated result is 40 km per hour. Jay cycled for 20 km with a speed of 40 km per hour in the first 30 minutes. Calculate the average speed in km per hour for the whole journey. To calculate the average speed, we must know the total distance traveled and the total elapsed time of his whole journey. Average speed equals to total distance divided by total time. The total distance for Jay is 20 plus 30 plus 50, and the total period, including the stationary period, that is 135 minutes. Converts to hour, 135 divided by 60. The average speed is 20 plus 30 plus 50 divided by 135 over 60. The calculated result is 44.44 km per hour. The next example is a speed time graph. The speed time graph shows the journey of a car for a period of 1 hour. A. Find the distance in kilometer traveled by the car at a uniform speed. Looks at the graph. The unit of speed is in km per hour. The unit of time is in minutes. Always remember to convert the minutes to hour for easy calculation. In a speed time graph, the distance traveled is always the area under the graph. The distance traveled at a uniform speed is the distance traveled along the flat line from 20 to 50 minutes from a rectangle in shape. Area of rectangle equals to length times breadth. With the length of 90 and breadth of 30 minutes, convert 30 minutes to hour. 30 divided by 60. The area of rectangle equals to 90 times 30 over 60 equals 45. The car travels 45 kilometers at a uniform speed. B. Find the total distance in kilometer traveled by the car. The total distance traveled is the area under the graph. To find the distance, we divide the graph into trapezium, rectangle, and triangle. Then find the area and add them. Firstly, the area of trapezium. Area of trapezium equals to 1 over 2 times sum of parallel sides times distance between them. Its parallel side 30 and 90, with a distance between the parallel lines of 20 minutes. Convert to hour, make it 20 over 60. Area of trapezium equals to 1 over 2 times 30 plus 90 in a bracket times 20 over 60. The calculated result is 20. The area of rectangle we calculate before, 45. And the area of triangle, 1 over 2 times base times height. With the height of 90 and the base of 10 minutes, convert to hour, become 10 over 60. 1 over 2 times 90 times 10 over 60 equals 7.5. Area of triangle equals 7.5. Add the areas together to find the total distance traveled. 20 plus 45 plus 7.5. The total distance traveled is equals to 72.5 kilometers. C. Find the rate of change of speed of the car in the first 20 minutes. Looks at the part in the first 20 minutes. The line is in upslope, imply that the speed is increasing. Hence, the rate of change of speed is defined as acceleration. Acceleration equals to the change of speed divided by the change in times. We can see the change of speed is 90 minus 30 equals 60 km per hour. And the change in time is 20 minutes. Convert minute to hour, 20 divided by 60. To calculate the acceleration, 60 divided by 20 over 60 equals to 180. The car accelerates at the rate of 180 km per hour square for the first 20 minutes. D. Find the rate of change of speed of the car in the last 10 minutes. The last 10 minutes is in downslope, negative gradient. This shows that the speed is in decreasing. Hence, the rate of change of speed is defined as deceleration. We can see the change of speed is 90 km per hour and the change in time is 10 minutes. Convert the time to hour, time divided by 60. To calculate deceleration, we divide speed by time. 90 divided by 10 over 60 equals 540. The car has a deceleration of 540 km per hour square in the last 10 minutes. The last example, the diagram shows a speed time graph for the movement of a particle for periods of 20 seconds. A. State the uniform speed in meter per second of the particle. There is no change of speed of a moving particle on the flat line. From the graph, the uniform speed of the particle is 14 meters per second. B. The distance traveled by the particle with uniform speed is 84 meters. Calculate the value of t. The distance traveled by the particle with uniform speed fell on the flat portion form a rectangle in shape. The distance traveled is the area under the graph. Distance traveled with uniform speed equals to 84. Area of rectangle equals to 84 with the length of 14 and the breadth of t minus 12. 14 times t minus 12 in the brackets equals to 84. Solve the equation. T is equals to 18 seconds. Replace t to 18. C. Calculate the average speed in meter per second of the particle for the period of 20 seconds. The average speed equals to total distance divided by total time. The total distance traveled is the area under the graph. To find the distance, we divide the graph into trapezium, rectangle, and triangle. Firstly, the area of trapezium. Area of trapezium equals to 1 over 2 times sum of parallel sides times distance between them. Its parallel side 23 and 14 with a distance between the parallel lines of 12. Area of trapezium equals to 1 over 2 times 23 plus 14 in a bracket times 12. The calculated result is 222. Area of rectangle is given 84. And the area of triangle 1 over 2 times base times height. With the base of 2, 20 minus 18 equals 2. And the height of 14. Area of triangle 1 over 2 times 2 times 14 equals to 14. The total distance traveled 222 plus 84 plus 14 equals to 320 meters. To calculate the average speed, total distance divided by total time. 320 divided by 20 equals to 16 meters per second. That's all. Thanks and see you.